Right, so in F, last one here, right? So I'm thinking about this as the natural log of u, where u is equal to the sine of the square root of e to the cosine of x. Right, so if I have the natural log of u and I take the derivative of the natural log of u, I'm just going to get 1 over u times u prime, or u prime over u. Right, so I already know something, right? I know my u is equal to the sine of this thing right there. But I need to find u prime. All right, so let me go find u prime. To find u prime, I have to take the derivative of this thing, but this is the sine of something that is not just an x, right? So I'm thinking about this now as the sine of, say, v, where v is the square root of e to the cosine of x. All right, so then if I take the derivative of the sine of v, I'm going to get the cosine of v times v prime. All right, so that's not too terrible. I'm going to get the cosine of e to the square root of e to the cosine of x. But now I have to find v prime. So I have to take this derivative. All right, but when I take that derivative, alas, right, it's the square root of something that's not just x. Right, so I'm thinking about this as v equals the square root of, say, w, just running out of things, where w is equal to e to the cosine of x. All right, so if I take the derivative of the cosine of w, I'm going to get w prime over 2 square root of w. And again, I know part of this, right? I know the w is e to the cosine of x. But alas, if I want to find w prime, w prime also involves a chain rule, right? So I have e to something that's not x. So I'm thinking of w as e. Uh-oh. Oh, did it just erase all of what I just wrote? I so did. It so did. How much did it erase? Damn it, I'm gonna pause this video to write what I had back there. I think that's where I ended up. All right, so I'm gonna think of this as e to the cosine. What's that to w? Wx. So we're not using an x or y. I'll do a z here. All right, so I'm thinking about this as e to the z at this point. Now w prime is going to where z is equal to the cosine of x. All right, so w prime is going to be e to the z times z prime. And finally, I can get that, right? E to the z is going to be e to the cosine of x. The derivative, z prime, is going to be negative sine of x. All right, so I'm going to get a negative sine of x here. So that's what w prime is equal to. So then v prime is negative e to the cosine of x, sine of x, all over 2 square root of w, which was e to the cosine of x. So that's v prime. But then, well, this whole thing is what's going in there, right? The cosine of v. So u prime is the cosine of v. And what was v? V was the square root of e to the cosine of x times my v prime, which is this right there. And so I would write this as, I would clean that up a tiny bit to get negative e to the cosine of x, sine of x times the cosine of the square root of e to the cosine of x in the numerator, all over 2 square root of e to the cosine of x. And these two terms here cannot cancel because this is inside the cosine, this is not. All right, so there's our u prime. Finally, let me just copy that and paste it up here. All right, so our u was the sine of the square root of e to the cosine of x. So that's in our denominator. I'm going to multiply this thing by my u prime, which was this. So if we're multiplying by those two things, this 2e to the cosine of x is going to go down the bottom. This is going to stay on the top. And there's really nothing that we can do there, but just for fun, just because this video is already taking, no one's even watching this video at this point. It's just me talking to myself. It's just, my mother wouldn't even watch this video. What a jerk move, right? Like, Don't you want your son to be successful? Don't you want your son to succeed? You can't even give me a pity watch on YouTube. Right, so sine of the square root of e to the cosine of x times the root of e to the cosine of x. And again, you can't multiply those two things together.